Polypeptide synthesis is the production of peptides, the building blocks to proteins. There are two main processes involved in the making of peptides: transcription and translation. Polypeptide synthesis starts in the nucleus, where DNA is stored. They contain a sugar-phosphate backbone supporting the base pairs inside. Transcription starts as an enzyme helicase unwinds the DNA by breaking the hydrogen bonds between the base pairs. This is when the RNA polymerase hooks onto the DNA and starts creating complementary bonds to each base. Cytosine and guanine complement each other, but for RNA, instead of adenine complementing thymine, thymine is replaced with uracil. Once the RNA has finished copying, it binds together to create messenger RNA, or mRNA for short. This mRNA contains the coding information to create proteins, but not all are useful. The unimportant parts, called introns, get removed from the strand of RNA, and the rest, called exons, are then spliced back together to form the final mRNA. mRNA then leaves the nucleus through nuclear pores and into the cytoplasm, where it finds a ribosome made from ribosomal RNA, rRNA for short. The mRNA hooks onto the ribosome, where the next main step, translation, occurs. The ribosome reads the mRNA in increments of 3 bases, called a codon. Transfer RNA, tRNA for short, are found within the cytosol inside the cytoplasm. These carry around an anticodon, which complement the mRNA codons, and an amino acid on the other end. In translation, a corresponding tRNA enters the ribosome, and its anticodon matches up with the start codon, AUG, from the mRNA sequence. As the next tRNA works through the process, the initial tRNA then detaches and leaves the ribosome. This, in turn, creates a growing chain of amino acids as translation continues. Eventually, a stop codon will appear and match with the tRNA, terminating the process and leaving us with a polypeptide chain that will eventually become a protein.